how did you all do with this assignment?
It was. I did actually pretty good on it.
It was okay.
All right, well, let's go ahead and swing some of this information. First of all, if you look with me on page 162, you see that triangles are what?
Triangles.
Well, they're more than that. Triangles are polygons with how many sides?
3. They have 55 sides. No, they don't.
I don't want comments, guys, because it gets us off track, okay? All right, so a triangle is named by the symbol. Here's the symbol, okay? That's your symbol. Everybody see this up here? That's important, okay? So if you have a triangle that is like this, each one of these vertices or vertex will have a letter with a capital letter that names that, okay? And so when you, what do they call it? Label or named, okay? So this triangle would be angle A, B, C, or triangle C, B, A. And it could also, that's the two best ways to, yeah. CBA or ABC.
Not BCA?
CBA or ABC.
Oh.
Okay.
I was thinking.
Okay. Now, one very important thing you need to know that is when you have a triangle, okay, this is an angle. Everybody looking up here? I'm not seeing all eyes up here. This is an angle, and this is an angle, okay? So if you add, let's just say this is angle A, this is angle B, and this is angle C. If you add angle A plus angle B plus angle C, that is going to always equal how much? 180 degrees, okay? It's like a supplementary angle, but this is a, and think about it, it is really like a supplementary angle if you think about it, but we won't think about it. We'll just leave it like that. But if you add the measurement of all three angles, you get 180 degrees. So let's say that you have a triangle. And we're talking about the measurement of the angles, okay? There's a difference between the measurement of the angles and the measurement of the sides of the angles, okay? Remember, the angles are always measured in what measurement? Degrees, okay? Degrees. Sides are measured in like inches, centimeters, meters, things like that, feet, yes. So let me just sort of say that this angle here is 90, let me just name them. A, of course my pen stops. So angle A, B, C, all right? So angle A, B, C. You see how this little half circle is drawn there? That it's indication that you're referring to the angle. So let's say that angle A, remember that's the sign for angle, right? And they still use that here. So angle A equals 45 degrees. Okay, I'm just making this up as I go. Angle C equals 65 degrees. How am I going to find out what angle B is? What am I going to do? Yes, Joanna?
Add both of those together?
Yes, I'm going to add 45 plus 65, which equals what? 110. Now, I'm going to take the maximum, the maximum is 180. I'm going to subtract 110, and that's going to give me what? 70, and so that's what the measurement of angle B is. Does that make sense, guys?
Yeah.
You understand how to do that now? All right. Now, because you will be doing that quite a bit. Now, let's just quickly talk about the types of triangles, okay? So you have an acute triangle, which has how many acute angles?
3.
3 acute angles. Everybody look with me on 162. An obtuse angle has 1 obtuse and 2 acute angles. You'll need to know these. A right triangle always has 1 right angle and 2 acute. An equiangular triangle has 3 equal sides. Now that equal there in the name, but that's referring to an angle. Now, you have learned about equilateral triangle, isosceles triangle, and a scalene, right? So, all right, so if you looked at these 2 triangles, would you let me finish? Thank you. Okay. If you look at these 2, and we're not talking about congruent, we're talking about equilateral, isosceles. So that's why you need to let me do the lead here, okay? All right. So if you look at these 2 triangles, would you agree that they are the exact same type of angle?
Yes.
Triangle. Would you agree they are the exact same size?
Maybe.
Yes. So an equilateral triangle has all equal sides. Equilateral, okay? So now let's just say that we have now these 2 triangles. They're the same shape, but it has, well, no, that's, okay. No, we don't want to do that right now. Let me put another one up here, okay? All right, this one is hard to see because it's on a black screen. But if you can imagine this, and you have lines that go through it like this, that tells you that it's what?
An equilateral.
An isosceles triangle. It has at least 2 sides that are equal. But could it be an equilateral triangle? How would you know that?
They're all the same.
You have symbols here that tell you all 3 sides are equals. If they have the same equal, it looks like an equal sign, but they're lines. Okay, so let's say you have a triangle like this. Then you know these 2 sides are going to be equal, right? If you see lines like that. Now, so an isosceles has at least 2 equal sides, which is this right here is an isosceles triangle. A scalene is when there's nothing to scale, okay? If nothing is to scale, nothing, you have no equal sides, okay? Yes. Number 1, how many acute angles are in a right triangle? Yes, 2. Number 2, what's it say? What is the sum of the angles of a triangle? Noah? 180. Number 3, how many vertices does a triangle have?
3.
3. Okay, got 2 people here with me today. Number 4, what is equal in an equiangular triangle? Yes.
The angles.
The angles. All 3 angles. Very good. All 3 angles. Number 5. What is the name for a triangle with 3 equal angles?
Equilateral or something like that.
Equiangular.
Equiangular.
Okay? EQUIANGULAR. Okay? Now, I'm a math person. Yeah, so you're fine. All right, number 6. How many equal sides does a scalene triangle have?
3.
None. 0.
Why am I so stupid?
You're not. Number 7, what is the symbol for a triangle? I'm just going to draw it here for you.
Mini triangle.
It's a mini triangle, absolutely. Number 8, is an equilateral triangle an isosceles triangle? Explain your answer. Yes, Noah?
By itself, no, because all sides are equal, but it can be an isosceles whereas I'm trying
Exactly. Yes, exactly. It could be, but,
by itself, no.
you know, typically it's either one or the other. Because if you have a triangle, you only have 3 sides, and if 2 of them are equal and the other one is not, then it doesn't classify as a equilateral triangle. It would be isosceles, okay? Now, did we do 9?
We did 9 through 12.
Okay, let's look at number 9. Here you have a triangle ABC. It tells us that angle A equals 40. Angle B equals 60. Now, we need to find out what the measurement of angle C is. Okay? So you would add these two together, which equals what? 100. And you're going to subtract that from 180, and so what is left over? 80. 80 degrees. Okay? Nope. Number 10, your answer should be 50 degrees.
Can I tell the next one?
Number 11, yes, go ahead, Joanna.
65.
65. Number 12, go ahead, Joanna.
60.
60 degrees.
Yay.
So number 13, your answer should be right triangle.
Wait, I have a question.
Okay?
I don't think I turned the actual paper or anything on this, so can I tell you that I did the work this term?
Yes, you can here in just a moment, because I'm going to look and see who has and has not. Isosceles for number 14. Number 15 is equilateral.
Can I tell the next one?
Yes, go ahead, Joanne. Number 16.
Same thing as 15. Equilateral.
Equilateral.
Wait, what was number 14 again?
It's on the TV, isosceles. All right. All right, any questions on that so far? All right, now, go ahead and go over to page 167. Okay, now, and then we will, we don't have a lot of time, but I at least want to introduce circles to you, okay? So a circle is a closed figure, right? Okay? All the points on a circle, would you say are equally distant from its center?
Yes.
Yes. And I know this is not going to be exactly in the center. But from this point to that point, this point to that point, this point to that point to that point, are all going to be equal. Okay? Now, a circle is usually named by its center. For example, this would be A. Let's just say this is C. We got B over here, and I'm making this up, D and E. Okay? So, a circle is usually named by its center. Therefore, the name of the circle in figure 1 is circle A. Okay? And this, the same thing. What would be the name of this? Circle A. Okay? Now, we also know that if you have a circle, and here's your center point, and you go from here to here. Hey! Is this anyone's lunchbox?
No.
Maybe 6th graders. Okay.
Thank you. All right, so if you go from the center point to the side, that's half of the circle. That is called your what?
Radius?
Radius. We did this last year, okay? So let's say that we have from here to here. What is that called?
Okay, I actually have 2 questions. Also, so when you say last year, do you mean 2020 or 2019?
I meant school, the last year's school year.
Okay.
Okay?
Also, I learned a little bit about this
All right, so again, let me just draw this again before we have to go. So you have a, well, gee, golly whiz. All right, so let's say this is our central point here. This is our central point here. From here to here is our radius. If we go from here through the line, this is diameter, okay? That's important to know. Now, the diameter is a line, let me back up here. If you had, let's just say, well, okay. If you have, if you have a line from here to here, does anybody know what that line is called?
Chord.
That is called a chord. Why? Well, let's look at what a chord is. A chord is a line segment whose endpoints are on the circle. In other words, it does not go through, but a chord, let's just say this is A, B, C, D. You would have A, B with a line over it. Okay? Now, let's say that you have from here to here. That's called a what?
Semicircle.
It is a semicircle, okay? And you would label that as with this symbol here, okay? Which would be A,
Very disinformed.
D, C is a semicircle, okay?
It's a deformed rainbow for the sun.
Okay, so to indicate the diameter or radius, you're going to have, like if you have A, B, C, then if you said from A, B, that tells you that when you look at this diagram, that's going to be the radius. But if it said from C, A, B, then that you know that would be what? The diameter. Actually, this textbook doesn't include all three letters. They just do C and B. And that tells you it goes from here to here, and that's the diameter.